not only undergraduates and postgraduates, but also academics and whoever who is interested. So this workshop, as you know, is a very important one for all of us, including people as seniors myself. So our programming, our statistics for beginners. So let me very briefly introduce, I think we all should know a little bit about the really fantastic resource person we are having today. So Dr. Samira Viswakula graduated in 2008 with a BSc, first class honors in statistics from the University of Colombo. And he obtained his MSc in 2011 from the University of Texas at El Paso in the US. And he went on to read for his PhD in genomic biostatistics, and he obtained his PhD in 2015 from the old Dominion University of the US. So he has also, no wonder he's such a good teacher. He has obtained certification, both locally CTHE, Certificate of Teaching for Education, and also from CEDA, that is a UK institution that gives accreditation for teaching in higher education. So both these Dr. Viswakula has obtained. I know it's such a lot of work, Samira. Congratulations. And currently, Samira is the director of the Center for Data Science under the Department of Statistics of our faculty of the University of Colombo. So without much ado, let me call upon Dr. Samira Viswakula to start off the workshop. And it's a 3-hour workshop, so I hope there are still numbers adding up. So Samira, over to you. Thank you very much.
Thanks a lot, madam, for the nice introduction. Thank you. Welcome to the workshop. I'm Samira. So how this workshop would be happening is you can message me at any time. I'll be sharing some slides. Also, I'll be doing coding live, right? So you can follow me and also type along with me and follow the codes and learn. You can stop me at any time. You can basically message me, then I'll be referring to the message just and answering your questions. So in the chat area, you can see the workshop folder where I'll be sharing some data sets and important files. So I think we can get started. Thank you. Okay. So I think you can see my PDF. These are the software we need. We'll be using R, of course, a statistical software, and the IDE, RStudio, right? So I hope you could install it by now. In case if you could not, you can go to that folder and find the links. In the chat area, you can find the folder, shared folder. There's a file which says the software requirement. You can install them. Right, so once you install them, you can go to the start menu, and so these are two things, okay? R and RStudio are two things. Back in the day, we only had R. Now we have this IDE RStudio. If you are familiar with some other programming languages like Java, right? So Java is the environment, and NetBeans or some Eclipse or something, that is the IDE. It's like that, right? So in R also we have the software, and then we have the IDE. So once you install R, you can go to the start menu and open that software, right? So it should be like this, the R software, right? So now the current version is R 4.1.0. My version is a bit old, but works well, right? So once you open R, right, if you go to the start menu and open it, there are actually two icons. You can see two icons, basically two. Let me share the screen and show you. right? Because these things important. So if you go to the start menu, right, and go to R, right, so you will see basically two icons like this, right? So one with the I and one with 64. So if your OS operating system is a 64-bit operating system, Windows 64-bit, right? Then you should open this one. If it is a 32-bit one, go with this one with the I, right? Okay. So because it matters your performance in your computer. If you are using a 64-bit computer and if you are using 32-bit OS, right, then you can't get the maximum out of your R and your laptop, right? So open the correct one, right? So once you open R, you will get something like this, right? Okay. If you come up to this point, please let me know. You can see the yes and no buttons in the chat area or in the reactions. Hit yes if you could open this one, at least few. Right, thank you. So this is the command line, right? In R, we have the console, R console, and you can see this greater than sign. This is where we code or we enter our commands. So make sure there's a greater than sign every time before executing a command. If it is not there, which means something is wrong, which means you are maybe at the middle of some other code or some error is happening, right? So in order to execute a command, this greater than sign should be there. For example, if I want to add 1 plus 1, right? You type in 1 plus 1, right? Then hit enter. Then it would execute and get the answer, right? It's simple as that. Okay. That's how R works, right? Now the thing is, when we are doing some advanced programming or advanced data analysis, this R environment or the R software, the basic software is not that helpful. So what we do is we go for this IDE R Studio, this one. So if you go to the start menu and open R Studio, you will get something like this. So from here onward, I'll be using this R Studio, right? R Studio, okay? So go to the start menu or from the desktop, you can open R Studio, right? So from here onward, I'll be using R Studio because this is very easy. There are several menu options available, and there are a lot of things that we can do through R Studio than just basic R. Still, we are using the programming language R, but through this IDE, right? Interactive Development Environment, IDE, R Studio, right? So when you are citing your software in a research paper or something, still you have used R 4.0.2, or probably your version should be R 4.1.0. You never should say R Studio. R Studio is just a software, an IDE, not the language, right? So keep that in mind. So you are using R in order, even though you are using this R Studio software, you are using the R language. So when you are citing, you have to say this, not R Studio. If you do R Studio, which means the editors or the other people know that you have no idea about R or R Studio, right? So keep that in mind, right? All right. Now, as you can see, we have this greater than sign, right? So you can execute a command by simply typing in a command. Let's say I want to add 1 and 1 plus 1, 1 plus 1, right? I'm sorry. So usual practice is like this. So we can do 1 plus 1. But in order to easy to read the command later, what programmers do is they usually give a space, 1 space plus space 1, right? Then it is really easy for us to read. or someone else to read the code, right? So what we can do is, right, as a habit, you can just do 1 plus 1. So it's very easy to read, right? You can just enter the command, then it would print, execute, and print the output, right? Okay. This space is not important. I mean, it's not a requirement. It's optional. It is for our convenience, right? Okay. Now let me take you to the program and the workshop. Right now, all set. I hope everybody is having RStudio up and running. Okay. So these are some major learning outcomes, right? After successful completion of this workshop, that is around 5 o'clock, you should be able to do these things. Work with different data types and structures in R. Write your own functions in R. Visualize data using R. Simulate some data sets using R. So you should be able to do these things at the end of this workshop, right? Don't worry, you'll be fine. It will be very easy. Even though if you're opening RStudio for the first time or RO RStudio for the first time, you should be fine. It's very easy, right? So R is an open source and free software. R is meant for statistical computing, right? Free and open source, right? Free means it's free, you don't have to pay. Open source means code is open. So our statistical software, this environment, somebody has to write a code and develop it, right? That code is open for anyone. I can go to the website and I can download it, right? I have the access. So that is what is called open source. It's both free and open source. That is, if I want, I can change the code and do some changes, right? So, let me give a very brief history in a real quick. So back in the day, in Bell Labs or AT&T Bell Labs, they were using this S programming language, basically, right? So it was very expensive. Only industry people could do it, could afford it. People like us academics, they couldn't afford to buy that software. So what these two people did was, they were from the University of Auckland, Rose Ihaka and Robert Gentleman. They started writing their own programming language. And in 1991, they started. In 1992, they came up with this programming language. So they used their first letters of the first names as their language R. That is how all started. Now it's like 30 years. Okay. So there are more than 13,000 R packages available. And there's a huge, very supportive R community out there. If you have any questions, you can post, and they will really, they are very helpful. They will help you to figure that out. Even there are plenty of web links available, forums available. So it's very easy to work with R. Right. Then I hope everything is clear. So this is just installing and downloading and installing the software, installing RStudio as well, right? So this is the R console, like I said. And like I showed you, this is how we basically execute a command. You hit enter. So you have to make sure this greater than sign is there, right? Okay. Sometimes there you will see a plus sign, right? If you have made a mistake, or if you are in the middle of some other code, you will see a plus sign instead of this greater than sign. So then no matter how many codes you execute, it doesn't work, right? So you have to get this greater than sign. How can you do that? If you see a plus sign or some other sign, in order to get a greater than sign, you have to hit the escape key in the keyboard. In the keyboard, you have this escape key. Hit that, then you will get this greater than sign, right? The other thing is, you can always restart your computer, right? But it's not recommended. So you can hit the escape key, right? Okay. So we'll do some execute some codes. Let me change the settings. Right. Okay. So if you want to execute a command, right, you can go to this R console, right? This is R Studio. Our console is there, right? And there are some other panels as well. We'll cover one by one. So this is the console. You have this is where we type in the commands. We hit enter, then the code will get executed. Then if you see here, you can see the environment tab, history, and all. Environment is when we are working with a data set or some variables, all these things will be shown here under the environment. You will see in a little while, right? And here you have this files, plots, packages here. So files means it's just a browser. Plots means when you generate a plot, those plots will show here, right? And sometimes we have to work with some external packages like libraries. So once you can deal with them under this tab. If you want to refer to the help, right? Let's say you don't have access to internet, right? Then R has a very good help. You can go to this tab and search on it, right? These are the basic things, okay? If you have any questions, you can post in the chat area, right? Okay, then if you want to exit R, you can just type in this Q with the parentheses, then it will exit, or else you can just close the program, like what we do in Windows. Just hit this cross, then it will close the program, right? Okay, then we'll do some simple computations. That is basically I'm using R as a calculator, right? So if you want to subtract 3 from 10, right? So you can just say, right? You can follow along and type along with me. That way you will also learn, right? You can practice basically. So if you want to add two numbers, like I said, 10 plus 3, if you want to multiply, if you want to divide, right? Let's say you want to get the 10 to the cubed, right? So either you can do 10, 3, or you can do 10, 2 asterisks with 3 in order to get 10 cubed, right? In order to raise the power, you can use 2 asterisks basically, right? Okay, so that is basically using R as a calculator, all right? Now, when we are doing our analysis or some, let's say a homework or a thesis or analysis or some consultancy project, we'll be using a lot of codes, right? So it is not that convenient for us to go with this command line. So what we do is we take a like a notepad like thing, a text file, right? It's called a script, right? So what we do is we go to the file menu and open a new file, R script, right? Go to the file menu, new file, R script. Then you will get a script like this. So this is called the script, right? This is where we'll be coding here onwards, right? So you have untitled, which means we haven't saved it. We just opened it, right? So it's untitled. So this is the script, right? So this shows the line number. I have only one line for the time being, right? Let's say I have 10. I want to add 5 to that, right? But now if you hit enter, what happens is the cursor would take you to the next line, right? It did not work. It did not run. In order to run this command, right? If you are on a script, as you can see, if you hit enter, the cursor will go to the next line. It doesn't get executed, right? So in order to run this command, there are several things that you can do. First thing is you can go to this run button, right? There's a run button. So you can hit that button. You don't need to select this, right? In some other programming languages, you have to select that, right? But if you are executing everything, right, you don't need to select that. You can just be on anywhere on that line. Either it can be at the beginning or at the in middle or at the end, anywhere, right? You can be anywhere on that line and just hit this button, right? Then it gets executed, right? That is how you run a code here onward. So after I'm done with these basics, I can jump into the R programming. So these things are very important, right? Otherwise, you won't be able to execute any command. So when you are on a script file, you can't just enter the hit enter. If you want to run the command, you can just run this command, or the other option is you can select it and run it, right? Select it and run the command, right? The other one is you can hit control enter. That's the shortcut key, right? Shortcut keys, control key plus enter. So that is what I'm using. No need to press any buttons. Once you are done with the code, you just hit control enter. It will execute that line or a bunch of lines, right? So you go to the one person is asking how to get the script. So you go to the file menu, new file, R script, right? File menu, new file, R script. Once you get the R script, you will get something like this. So you can type in the command like this, and either you can hit this run button or do a control enter, or you can select it and run it, right? Okay. So now you know how to work with scripts, right? Another milestone, right? Okay. Now, sometimes we have to search on some functions, right? So let's say I don't know how to find the main. So what I can do is I can type in the command. Let's say I know the function, but I don't know how to use it. I know that in order to find the average, the function is mean. But let's say I don't know the how to use it. You can just do help with the function name, or you can put a question mark and the function name. It would take you to the help file. For example, if I want to go to the help file dedicated for this mean function, all I'm doing is question mark mean, control enter, then it would take you to the corresponding help file, arithmetic mean. So one best thing about this R help is most of the time at the very end, at the bottom, you can find an example, one or more examples. So it basically shows you how to use that function. It's really helpful. Otherwise, you can just Google, right? Average in R. It will show you, Google would, the browser would show you bunch of examples, right? Again, if you don't have an access internet or something, right, then you can go to this help, right? So see, I'm using this help tab, right? Here we have this help tab. In the help tab, I am typing, either you can type in here, right? Find, here, you can say mean, right? Once you hit the mean, type in the hit mean and hit enter, you will get the same thing, right? Or else you can put a question mark and the name of the function, right? Okay, that is how you go to the help file, right? Sometimes you don't need to read. Let's say I know the function, but I don't know what the arguments are. Argument in the sense, this is again important. When you have a function, let's say mean is the function, right? And within the parameters, we need to specify the arguments. Argument 1, argument 2, right? Most of the time we have to give the data set, right? Let's say data. Then a second argument would be, are we finding the weighted mean, or what should we do when we have missing values? Likewise, There can be several other things. So those should be specified as arguments, right? So if you want to see what the arguments are for a given specific function, args function would give you those, right? You can just say args mean, right? Then it should show you what the arguments are, right? Right, again, you can Google and very easily get these things, right? Okay. Right. Okay, I'll come back to these packages, right? So there are some inbuilt constants available, right? For example, we all know what the value of pi is, at least approximated value, right? So those things are commonly used constants. Those are saved in R as constants, right? So if I want to get that value, you can just say pi, right? Or you can say print pi, right? Then it would show you the value of that pi, right? So you can just say pi, right? 3.141593. It's giving us for up to 6 decimal places, right? So if you want to find the area of a circle, right? You know it's pi r squared, right? Once you specify the radius, you can find the area. For that, you can use this pi. So likewise, there are several constants available. You can get the use of that, right? Now, as you can might have seen, so there's a command called print. Yes, if you want to print a value inside a variable, you can use the print command, right? So when you say print pi, same thing. Either you can type in the variable name or you can use the print command, right? Print is helpful when you are working with a loop, right? Most of the time, so that we can ask the loop to print it. Otherwise, the loop might get confused, right? If you just say the variable name, right? So you will learn them later. So for the time being, there's another command called print. If you want to print a value which is stored in a variable, right? I'll properly cover these variables in a little while, but before that, let me introduce these variables. R has different data types, character data type, numeric, logical, likewise. So if you want to create a variable, let's say I want to create a numeric variable, right? Let's say I want to say save this 10.5 in a variable in R, right? So I'm gonna say just X. I'm gonna store this 10.5 in this value X. So when I execute this code, what happens is R is going to create this numeric variable X. That's it. You don't need any semicolons or anything. You don't need to define the data type. You don't want to say double or something. C++ or Java programmers, you may be familiar with these things, but you don't need these things, right? You don't need a semicolon at the end. You don't need to define the data type. You can just say X equals that value. That's it. That is why R is very easy. You can say just 10.5, right? Once I run this command, R is going to create this variable. Usually we don't say variable, the name variable when it comes to R. We call them objects, right? So objects, I just created this object X, right? Object X has this numeric value 10.5, right? That is how we say. So I just created this object X, little x, right? Also, R is case sensitive, right? Case sensitive in the sense capital X and simple x are two things when it comes to R. So if you say X is equal to 10, little x equals to 15. So when you are referring to that particular variable, you have to be very careful. Otherwise, your entire simulation or your entire analysis would be wrong. So R is case sensitive. Keep that in mind, right? So now we have just created this X name, right? So I ran it. Now, everything is okay. No warnings or no errors. So we are good to go. So now if you go to this environment tab, you should be able to see that, right? I just created this X object. Now it's there, which means it went well, it worked, right? You are good to go, right? Okay, that is how you double check whether your code worked, right? Now you can just say print X, it's printing, or you can just say X, right? You assign the value to an object and you are printing it, right? Okay, right. Okay, please hit yes or no buttons. If if it is clear, please hit yes. Otherwise, please hit no. Right, thank you. Okay, right. Then, so there's another command which is cat, right? So let me show you why we need another command to printing, right? Environment window is in the RStudio. If you go to the RStudio, usually it's on the right hand side top. So if you are make sure it's not R, it's the RStudio, right? So if you go to the RStudio, and I'm working on the RStudio, not just R. In the RStudio, this environment tab should be there on the right hand side top. Right. Please let me know if there are any other questions. Right. Now, why do we need another command, right? Let's say I want to combine some text messages or a sentence with a variable like this. So I am working with, I'm finding the area of a unit circle, right? Unit circle in the sense I used a circle with the unit radius. Radius is 1 basically, right? So we know how to find the area, pi r squared, r is 1 basically. So I want to print the area of the unit circle is pi r squared, and I'm printing the value, right? So I'm in the print command, inside the print command, I'm combining, putting a comma, this text, right, with some variable value, pi r squared, right? But the thing is, we can't do this using the print command. Basically, print command does not allow us to combine this character type and this numeric type. So basically, you can't combine multiple things in a print command. So for a scenario like this, we had to go for a cat, right? So when you're printing something, you might find this helpful, right? Okay. Right. So let me in a real quick. So maybe I can just say here, right? Print area is, right? Then if you put a comma, right? And if you just say pi r is 1 squared, right? It would not print the value. So if you want to print that value, you have to do a cat, right? You can just say cat area is, then a comma, sorry, this should be inside, okay? Right? So once you run this, now you can see text message and the answer, right? This comes sometimes this is very helpful because you need to present your answer at the end after running some codes. Maybe you are finding some likelihood values or some other value related to your research. You need to clearly label them properly, right? Otherwise, at the end of the code, there will be several outputs. You won't be able to recognize them properly. So these things are very important. Cat, right? Usually, cat, after the cat command, we had to introduce the new line command. Basically, what I'm saying is the print command, after printing, the cursor goes to the next line automatically, right? But in the cat command, it does not like that. It doesn't work like that. So you need to, I know maybe this is overwhelming, but just for the completion, I'm telling this. So I need to use a \n. So this would make sure the cursor goes to the next line. This is the new line command, right? So after printing this, take the cursor to the new line. So since there's only one here, you don't see any difference. But if you are printing this inside the loop, you will see this, right? So this \n is the new line command, right? As you can see, what I'm doing is commenting. So this is how we comment in R. We use a hash key or a pound key, right? Then we can make the comment. So basically, this is a comment, right? So it is not going to get executed. It's a comment. So this is how in R, this is how we comment. Use a pound key or the hash key, and you can make your comment, right? So someone is asking why should download R as well as for RStudio. RStudio is the IDE only. If you do not install R, you won't be able to run this. So R has everything, and RStudio is the IDE only, right? If you just install RStudio, you won't be able to do this. So you have to first install R, then install RStudio. So when I'm running a command in the background, it uses R, right? I hope it's clear, right? Good question. Right. Then, right. Another important thing, that is this assignment, right? So I told you this R was developed after this S language. In the S language, they were using this arrow notation. Arrow notation in the sense, this arrow or this arrow. This is an arrow. Hyphen, greater than sign or less than sign, hyphen, right? In S language, if I want to assign this value 10 to this variable X or this object X, I can do this arrow. What this means is I'm assigning this value 10 in this X variable, right? Less than sign, hyphen, right? Assigning value 10 in X, right? That is what this hyphen, arrow notation does. So R was developed after SNET. So all these S commands, majority of these S commands also work in R. So in R also we can use this. So when you're referring to books or internet material, you will see that this arrow notation. So don't panic. It's just the same as this assignment. So one can say, I'm assigning value 10 to X, or same thing, right? Both are same, right? I usually use this assignment operator because it's easy. I don't need to type in two keys, right? But one of the advantages of using this arrow is one can say, I'm assigning this 10 in X in this direction as well, right? In some cases, maybe you want to do this. So I'm assigning this 10 in X, right? But you can never say 10 is equal to X. This is wrong, right? You cannot. What this means is you are assigning this X here. You can't assign a variable to a numeric value, right? This is wrong. But if you're using this arrow notation, this works, right? Okay. So setting a variable can be done either using an assignment of operator or using the arrow notation, right? Okay. Right. Then, right. So R is case sensitive, which means, let me show you. I'll use A so that you can see the difference, capital and simple, right? So you have capital A and little a, right? So if you print capital A, now it's 10, right? But if you print little a, it's 5. So R is case sensitive, right? Keep that in mind. There, I know some other programming languages like SAS, right? Those are not case sensitive, but R is case sensitive, right? And also R is a dynamically typed language. What does that mean? Which means in this instance, A is 10, right? In a little while, I'm going to say A is 20. No issues, right? A is 20, right? In a little while, I'm going to say A is apple, right? Doesn't matter, R accepts it, right? And it stores that value. So previously it had a numeric value, right? This is a numeric value, numeric values. I just change it without erasing the memory location, without resetting the memory location. If you're working with C or C++ or Java, you have to do this separately. And especially when you are changing the data type. So these are numeric data types. This is character. So when you are specially changing the data type, you can't simply do it in most of the other programming languages, right? So, but R is a dynamically typed language. So it's, in a way, it's very helpful. Also, it's very dangerous. In the middle of your code, if you make a mistake, then you would even know, you wouldn't even know, right? Because R is not giving any errors also. It's doing its job, right? So you have to be very careful. You can change the data type very easily like this, right? Okay, so at the same time, I'm now introducing another data type. So these are numeric data types, right? Numeric. So this is a character data type. When you have a character data type, I mean character variable, you have to use double quotes. Within double quotes or within single quotes only, you can define a character. So let's say you can say orange. Y is equal to orange, right? Or you can say Z is equal to mango, something like that, right? So character data types should be handled very carefully, right? All right. Then sometimes we have to combine more than one value, right? Let's say we have something like this. We have a variable W, and I want to store more than one values. Let's say I have some values, let's say 10, 20, 30, right? I want to store all these three in this variable W, or in R's language, I want to store all these three in this W object. How can I do that? It's very easy. You have W, right? So I have 10, 20, 30. You can't just simply do that, right? You need to tell R that, okay, combine them. So you use C operator. Simple C, you are combining more than one value, right? C operator, okay? So that way you can combine these values. I'm running the code, and if you print W, now you can see all those three values are saved in this W object. Maybe you have some heights or some weight, some other expression level values, some resistance values, some current, right? So many things, you can store them in a single object, right? That is how you do it, okay? So now you know how to combine values as well, right? Okay. Similarly, you can combine some multiple character values as well. Let's say I'm creating a fruits. right? Object where I have several fruits, right? Orange, mango, right? Like this. Now if you do fruits, you can see those are saved in this object fruits, right? Okay. Hit yes or no if it is clear or not. If it is clear, hit yes, please. Otherwise, hit no, please. Right. Thank you. Right. Thanks. Right. Okay. Then sometimes we want to know how many data points are there in a single object, right? So let's say this is a very lengthy one. After the experiment, I mean, when I'm doing the experiment, I kept on entering this data and I saved them. Now I want to know how many observations are there, right? So you are not going to count them. You can use simple commands like length, right? Length of W. So it would say show us the length because W has only 3, right? So length of W gives the length of that object, right? Okay. Sometimes we want to find the average, right? Let's say I have some values, heights, likewise, I have 3 values, 3 heights, right? Now I want to find the average height, right? So one can do, what one can do is, one can simply do the old school way, 150.2 plus 146.8 plus, because R works as a calculator as well, right? So it should be fine, right? So this gives the sum and you can divide it by, divide the 486.4 by 3. That should be the average height, right? Or else one can do, you can get the sum using the sum function, right? And divide by 3. Or else one can do sum heights, you divide by the length of that vector. Sorry, not, I haven't introduced vectors yet. Object, let's say heights. Because this can be a very lengthy one also, so I'm not going to count it, right? Or else you can use the mean function, the built-in function in R, mean of the heights, right? There are several ways that we can use to get the, this done, right? You can follow these, right? So either you can add them and divide by the total, you can use the sum function, or you can use the length function also, and maybe you can use the mean, right? Okay, right. So that is how you do basic things. Similarly, you can find the standard deviation, right? It says in, just for illustration purposes, standard deviation or variance, right? Okay. Minimum, maximum, right? Or else you can use the summary function. Summary function gives most of the things at once. So if you use the summary function, right? If you use the summary function, you can get the minimum, maximum, then you can get the first quartile or Q1, Q2, Q3, sorry, Q3, maximum, and the mean, right? All right, summary function. Okay, right. So in case if you miss these numbers, you don't need to type in the same number. You can just say 10, 30, 40 or something and get these things done. The idea is to understand the function, right? Right. The specific questions I'll answer at the end, okay? Right, thank you. Um, okay, so you can just say x is, the height is 10, 30, 40, 50, some numbers, and you can follow along these codes and get your answers, right? Okay, right. Okay, then maybe if you want, I can copy and paste the code in the chat area, that if that helps, right? Right. Then we can move on. Right. So when we keep creating these objects, those things are shown under this um, environment tab, right? So here we have this object A, object capital A, fruits, heights, all the things are there, right? In addition to the values which are saved in these objects, these are the values. In addition to that, it gives the type also. So height is a numeric type, fruits is a character type. So it gives some description about the variables, right? Okay. Sometimes when we are working with a huge project, when you are doing a decent data analysis, maybe we are creating like hundreds of objects, right? So if you want to list them all, list all the objects, you can use this ls command, listing all the objects, right? Objects means variables, right? Basically, loosely speaking. So it shows all the variables that are there in this session. Okay, new word, session, right? So session means, maybe I'll write there itself, right? So session means R session, right? Session means when you open RStudio or R, right? Until you close it, right? From opening to closing, right? It's called a session, R session, right? This is important because if you save them, if you do not save them, certain things you will lose, right? Of course, if you do not save, you're going to lose, right? But this is a little bit different. The reason is there are multiple things going on when it comes to R or RStudio, right? So we have the codes. Also, we have the objects, right? Codes in the sense, these are the codes, right? Objects in the sense, when we run the codes, these objects are created. You see the difference? So once you run these codes, these are codes, right? Once you run these codes, maybe on a script file, right? These objects are created, right? So you need to save them separately. In a Microsoft Word document or an Excel document, you have only that, right? Whatever you do, you can save it very easily. But here it's not like that. If you just save the script file here, it's gonna save only this codes part. If you just save, so how do you save the script file? You can just go to this file menu and save, or else you can just hit this button. There's this save button. Under the script, you have this save button. You can just hit that button. Once you hit that button, you will get a dialog box like this, right? Maybe you can say R codes, right? So let me repeat that. you are on the script, you hit this button, save button, right? Once you hit that, you will be able to save it, right? Let's say R codes, and you can hit the save button. It will save the script file, right? So now it's successfully saved, right? The script. I have saved the script. So script file uses this extension .r, right? So I said R codes or something, right? R codes, and the extension is .r. Remember, in a Word document, we have docx, right? Or doc format. Similarly, for a R script, we have this .r extension, right? When I hit this save button and when I give the name, usually R gives this extension automatically, right? But if there are dots in your file name, this is very important. Let's say if I said R codes, and if I put this name date here, 24/7/21, there is a chance that R would get this 21 as the extension. That is, if there's dots only. As far as there are no dots in your file name, that's fine. But in case if you are using dots in the file, make sure when you are giving the file name, give this .r extension as well. That's it. Very simple, right? So as a habit, what I do is whenever I'm specifying the file, I give rcodes.r. Then life is easy, right? But if there are no dots in the file name, don't worry, just give the name only, right? Again, if there are dots in the file name, R might get confused, right, with the dots. So better to give this .r extension along with the file name, right? Okay. So now this script part or the codes part is done, right? Codes part is done, right? That is, I am saving the code. What about these objects? Once I save the code, it doesn't mean that I'm saving these objects. Of course, this is a very simple program. You can always open the script file and run it, and within like 10 seconds, you can create these objects. But when you are doing serious data analysis, serious simulations, your code might run for days or weeks. At our department, our students are running codes for like 2 weeks. Right? After 2 weeks or maybe 1 month, only these objects get created. Their probabilities or likelihood functions, values, they get created only after 2 weeks. So maybe let's say after 1 hour, even 1 hour is a huge amount, right? So if you do not save that object separately, then you have to wait another 2 weeks to run that value and get it again, right? You see my point? So if you do not save these objects whenever needed, you will have to rerun and get the objects. So it can be weeks or hours or days. So R has this option of saving this objects separately. Coding, of course, everybody save codes, but objects most of the time we don't, because we don't need them. But in case if your program is expensive, if it takes a lot of time to run, always save these objects as well. So how can you do that? So here you have this space button. You hit that button. Once you hit that button, it saves these objects, right? So I'm gonna go to the same folder. Let's say R objects, right? Then I'm gonna hit save, right? So as you can see, it ran this command, save.image command, right? And it gave this extension, right? I just wanted to emphasize on this. So here you have this .r data extension. So when you save these objects, the extension is .r data. For the scripts, it's .r. You see the difference? Script means the code only. Objects means once you run the code, you will create these objects. And if you want to save these objects separately, then you have to save them separate. So R would give you a separate extension .r data. So old school way of saving object is save.image function. Back in the day, before RStudio was coming to the picture, we did all this manually. We typed in all these commands and we save them separately. See, in the environment, the basic software, it doesn't have those fancy buttons, right? So you have to code everything, right? Now the life is easy. We have this RStudio, right? So you can save it like this. So if you go to the folder, you should be able to see those files, both of those files, one with .r, the other one with .r data, right? Okay, since I'm talking about these files now, let me talk about one important thing, that is the working directory, right? So when you are working on a project, you might deal with several files, right? Working directory. You might deal with several files, right? Let's say there are several data sets, right? Several data sets, maybe you want to save some images in that folder. So that folder is treated for that project. We have this directory. So loosely speaking, you can consider it as a working directory. So what a good programmer would do is, at the beginning of the, let's say once I open an RStudio session, the first thing I would do is I'm going to specify the working directory. That is basically I'm telling okay, this is my working directory. So that can be done like this. So you can go to the file menu, right? Then you can say, I can't see you, right? So file menu, hold on, file menu, where is this? Sorry, sessions, right? I'm really sorry. It's in the sessions, right? Set working directory, choose directory, right? So I'm in the process of specifying the working directory. I'm telling R, hey, this is the working directory. I'll be dealing files. I'll be working with the files in this folder. That way, my life is easy. Otherwise, every time I have to give the full path. I have to say C program files or R, C my documents or research folder. Likewise, I have to specify the full path. So what I'm doing is I'm going to sessions, working directory, and choose directory. Let's say this is my working directory. I just specified that working directory, right? Then hit open. Then you are all set, right? So that folder has all your files, right? Now your life is easy. Otherwise, whenever you are saving a file or importing a file or something like that, you have to specify the full path like this, right? Once you do this, you just need to, I'll talk about this in detail when I'm importing files, but for the time being, this is how you set the working directory. So if you are a serious programmer, this is how we do it using codes, get working directory. This would show us the working directory, right? And if you want to set the working directory, set WD, and you need to specify the path, right? So let's say here, this is my path to that folder, full path within double quotes. So this is a one-time thing, right? Once I set the working directory, I don't no longer need to specify the full path. I can just go with the file name, right? The reason I'm discussing this here is this is also important if you happen to use these full paths in R, right? And if you are working on a Windows environment, please keep this in mind. So in Windows uses these backslashes to break the folders, right? this S language, then we had this R language. These were developed under Linux environment, right? In Linux, they don't use these backslashes. They use the forward slash, right? That is why when we are doing when we are using the menus, it's using this. See, they are using forward slashes. I got this done based on, I mean, using a menu. I save the image using this button, right? I set the working directory under the sessions menu. So when R is doing it, it automatically uses these forward slashes. But if you happen to do this manually, after copying this path, you have to unfortunately replace these backslashes into forward slashes, right? But this is a one-time thing. I mean, if you are running this code, if you are coding this for a homework or something, a one-time thing, then no need of doing all this. You can just specify this the full path and do it. But let's say you are doing your thesis or a research or a project, and where you will be using the same code for several days. So each time you open the program, you will have to go to the sessions menu and browse through that folder and select it. But if you import, I mean, if you put this code, right, all you have to do is just run just 1 millisecond work, right? Otherwise, you will have to go to the menu and do it each day, right? So all you have to do is you got the full path, replace these backslashes with the folder slash. Now you are done, right? Now if you get this working directory, right? Now you can see that it's there, right? Now you can look at the files which are stored in the working directory by simply using the dir command, right? So I have several files saved in this working directory, data CSV, data text, right? All these, right, are there in the working directory. In fact, you can go to my shared folder and download those text files, these files into the folder, and you can specify that folder as the working directory for today, right? Then when you are importing the data sets, in a little while I'll be importing these things, then the life would be easy, right? Yes. Yes, madam. Each time we have to do that. Backslash and the forward slash change. Yes. Thank you. Right. Then let me real quick, right? So there are so many things that I had to cover, but I'm covering the basics, right? That way you can go from there, right? At least when you see them somewhere else, then you will understand, right? So now you know how to save these objects and the variables separately, right? Sometimes when you are working with, let's say, huge files, it's not that good to have these unwanted objects in your session, right? Let's say I'm done with this part. I got the mean, I got the standard deviation. Now I'm moving on. I no longer need these ones. So it's always better to clean our session, clean our memory. So by cleaning up, we can have a better performance, right? So if I'm done using these objects, I can very easily remove them using the rm command, right? Again, if you are doing a very simple program, no need to worry about these things. But if you are dealing with like hundreds of thousands of data points, and if you are doing so many computations, these things matter, right? So removing object A. I just removed this little A object. Now it's gone forever, right? So if you want to do this, remove this, let's say capital A, RM, right? Now it's no longer there. If you list them now, little a and capital A are no longer there, right? If you hit this broom like button, everything will be gone. So if you want to erase everything, right, you can still do that as well, but you have to be very careful when you are doing it. Otherwise, you will permanently lose some of the important stuff, or else you will have to wait for 2 weeks to get them again, right? As a habit, what some people do is they, at the very beginning of the code, maybe when they start the code, they start the session, they clear all the objects and have a fresh start, right? Okay, then right, moving on. Yeah, don't worry about this 158 because I have already talked about so many things, right? So when I'm discussing, explaining some stuff a little while ago, so don't worry. So if you want to, without hitting the broom like button, you can incorporate this command rm is equal to, remove list everything, right? If you do this, it would remove everything, right? It's similar to cleaning the, hitting the broom button, right? That is, again, some people prefer to have this code at the beginning of the code. So at the beginning of the code, I'm sorry, here at the beginning of the code, you put it here. I do not recommend that, but if you want, some people do this, right? Okay, then you will have you don't have the previous objects, right? Okay, right. Now vectors, right? So when you combine different objects, yes, a question is, can we change the working directory after assigning one at the beginning? Yes, of course. Anytime you can do it. All you have to do is go to the session menu and do it manually, or you can simply run this command, set working directory with the new path. You can, whenever you want, you can do that, right? So if you have numeric values, you can combine them using the C operator. If you have character values, you can combine them like this. In addition to that, we might have to deal with some logical values. True, false. In R, we use all caps, T, R, U, E. Then only R would know, okay, now we are talking about true, logical true. Or else you can do capital T, just T only. You cannot do this. This is wrong, right? So either you can go with this, or you can use the first letter only to define logical data types. You will rarely use these things, but good to know, right? Sometimes we have from different experiments, different data sets are coming. Now I want to combine them. Let's say from yesterday's lab work, I got this vector 1, 2, 3. Now from today's analysis, today's lab work, I got this. Now I want to combine these two and create a new object, right? So these are called vectors when you have more than one value, right? And when we use C operator to create them, we call it a vector, right? Typically, these are called atomic vectors, but for today's session, we'll say just vectors, right? So when you have combine operator separated by commas, basically you are creating a vector. So how do you combine vectors? So you can combine the vectors the same way. You use the C operator, combine operator. So this is little c, okay? R is case sensitive. If you just put capital C, then you won't be, probably you will get an error, right? So the same way you can combine vectors as well. I had 1, 2, 3, 4, 5, 6. I just combine this. Now you can find the average, standard deviation. Maybe you can plot them, right? For illustration purposes, I'm using 3 numbers, right? You can, of course, create 1, 2, 3. One might say, sir, isn't it easy to do this? Yes, of course, but get the point, right? So if you have millions of data, you can do this, right? See, combine 2 objects, right? Okay, right. Then, so similarly, character. So this is a character vector, right? We have characters, character vectors. Maybe you want to combine them as well. But the thing is, if you happen to combine a numeric vector with the character vector, right? Then it might lose some information. Because see, once I combine them, this numeric data also became characters within double quotes. So I won't be able to get the numeric summaries and all because I lost that information. When you are combining numeric data types and character types in a vector, right? Numeric values are also becoming character values. So there are some information loss, which means, in other words, you cannot combine, you cannot have different data types in a vector. So you have to go for a different data structure, right? We'll talk about that later, right? So there are remedies, of course, don't worry, right? But you should know it's not gonna work, right? Right. Then let me talk about some data types, right? So numeric, integer, complex, logical, and character. These are some commonly used data types in R, right? Numeric, we have already talked about numeric, right? So let's say 3.5. So it's a numeric value, right? Even if you say x is equal to 3, it's a decimal value or a numeric value. So numeric in the sense in R's terminology, decimal, right? So even if you say x is equal to 3, R is going to consider it as a numeric. So this is not an integer value to R, right? That is, if you are, let's say, dealing with a number of patients come into a clinic. Let's say today 3 patients came. So this is an integer value to me. But to R, it's 3.0, a decimal value, right? So you need to tell R, okay, this is not numeric. Consider it as an integer. So you can say as dot integer 3. Let's say y is 3. Then R would know, okay, now this is an integer. Otherwise, the default setting is R is going to consider this as a decimal, right? As dot integer, right? Similarly, there are this as dot character, as dot numeric. You can use them properly, right? This way we are telling R, right, that this 3 is an integer value, not a decimal value, right? So numeric data type. Then, like I said, integer, right? Properly defined, right? Then, so here we have this 3.14, but it has it is given as a character value within double quotes. Using this as dot integer function, we can extract this 3 integer part without a problem, right? Even though it was defined as a character, this function could extract this value, right? So there are these useful functions available, right? Okay. So of course you cannot convert a character into an integer, right? There's no meaning. So we have NA. NA means not available in R. NA means not available, right? Right. So complex numbers, if you happen to deal with the complex numbers, this is how you do it. So you have the real number and the complex number, right? That is how you handle it, right? Complex numbers. Those are very specific parts, so I'm gonna skip, right? So for example, square root of a negative number, it's not possible under usual setting, right? So NA ends in R means not a number, not a number, NaN, right? Okay, so if you want to find the square root of negative number, you have to define it as a complex number, right? So you know what I'm talking about, right? Then logical data types. So a very important data type. So let's say x is 1, y is 2. If you want to check whether this value of x is greater than y, here's how you do it. you check that is x greater than y. X is 1, y is 2. Is x greater than y? No. So false, right? So I am assigning that result in Z. So Z gives false, right? Is x greater than y? No, which means false. So this is a logical expression, and I just created a logical variable or an object, right? Okay, that is how you deal with logical data types, right? Okay, little by little you are learning and you are exploring the different data types, right? Here we have u, so it's true, it's set to true, and v set to false, right? I'm checking whether u and v are, I'm checking this AND operator, right? And means both should be true in order to get a true result, right? So one is true, the other one is false, so we have false. OR gate, right? U or V, at least one is true, so we have true. Not or negation, logical not. So you have this exclamation mark, right? And the logical object, so it gives no, false, right? So logical data types, right? Okay. Then if you want, you can convert a character data, I mean a numeric value into character using this as.character 3.14, right? I don't know why we are doing it, but if you want, you can do that as well, right? Now, one important thing, that is the paste command. So if you do C operator, right? So you have a object first Barack, last Obama, right? If you combine them using a C operator, what happens? Now you have Barack Obama, right? It's like this, A, B, right? Once you do A, B, what happens? You have two separate elements, A and B. That is what C operator does. But sometimes, especially when you are doing bioinformatics or DNA data, let's say, right? So you want to, let's say you have ACGT, you want to get a sequence like this. So you can use this paste command, right? So you have paste, first name, last name. Then it would be a single element, right? Paste command, right? Let me talk about some related stuff, right? So R has these letters, right? Little letters, in bit letters, 26 letters. So you can call them very easily letters. It has these capital letters as well, right? Okay, letters. If I want only the first 10 letters, right? You have to use a square bracket. Square bracket is the key, right? Square bracket. I need the first 10 from 1 to 10. Then it would extract the first 10. If you need the last 10, you can do that. If you need from 5 to 10, you can do that, right? Very easy, right? So which means this square bracket extracts vector elements, right? For example, let's say we have capital A, like this, right? So if I want to extract the first element from a vector, square bracket A, square bracket 1. If I want to extract only the third and the fourth, C 3, 4, right? So when you're dealing with hundreds of thousands of data, these are very helpful, right? Okay, square bracket. So this is called indexing in R, right? Indexing. Using an index, we extract the data. So when you have more than one index, we say subsetting, right? So now you know indexing and subsetting, right? So if you want the first 4, one can say extracting the first 4. Right? So one can say I need the first 4. Right? The naive way would be A1, A2 likewise, but it is not good, right? That is, you are extracting one by one, right? A very primitive way. Another person can say 1, 2, 3, 4, right? This is also not that good, right? We can use the sequences. Sequences, another new term, sequence. Sequence in sense, in R, we use a starting value, an ending value, a colon, a sequence, right? So if I need from 1 to 4, I can simply say 1 to 4. Yeah, a good question. One person is asking, is the first element in an R list referenced by 1 or 0? Very good question. Yeah, I was about to say that. So in some other programming languages, if you want to, let's say you have an array or something, and this is how we store the values, 1, 2, 3, 4. If you're using C-like language, if you want to extract the first element, that is the 0th element, right? It's the first element. If you want to get the second element, it's the first location. If you want to get the first element, that's the 0th location. Basically, k minus 1 we are using. But in R, it's just 1. If you want the 1, the first element, it's first element. If you want the second element, it's second element, right? That is how R works, right? It's a very good question, right? So it's not like this in R, it's like this. First, second, likewise, right? So sequence in the sense, so if you need from 1 to 10, 1 to 4, you have 1 colon 4, right? Then again, let's say you want to create a sequence. Sometimes when you are dealing with experiments, you want to create a sequence from 1 to 10. So you can very easily do that, 1 to 10, right? Sometimes you need from 10 to 1, right? Okay. Sometimes you need something like this, 2, 4, 6, 8. So how can I do this? 2, 4, 6, 8. You can do 1 to 4 multiplied by 2. 2, 4, 6, 8. Or else you can say 1 to 4. For undergraduates, I use this as a homework or a exercise, right? You can say 1 to 4, right? So you can create this 2, 4, 6, 8 like patterns as well, right? But if you have a complicated sequence, which is not very obvious, you can use the seek function. Seek, right? Seek, it's a, you need to specify as the first argument from, let's say from 1 to 100, right? And there's another argument by, let's say by 8. You can do that using the seek function, right? From 1 to 100 by 8. So you have the required sequence, right? Using the seek, right? For some of these functions, they have this default value, right? So let's say now I want to explore the seek function. So I'm going to the help page of the seek function, question mark seek, right? So help page shows me the argument list. So it has from equals 1, 2 equals 1, by equals likewise. So it has a value assigned to these arguments. These are called default values, right? That is, if you do not specify the value, that value is taken. For example, if you say seek, the default value of from is 1. If you say to 10, it should go from 1 because the default value is given in R as 1. So no need to specify that, right? Likewise, so let's say seek from 10, then technically it should go to 1, right? No, it didn't. Why? From 10, for some reason, yeah, it did not work as I thought, right? Anyway, the default values are there, right? If the from is not given, it's going to take as 1. If the 2 is not given, it's going to take as 2. So we can say by -1 or something, right? Now you have 10, 9, 8, 7 up to 1. So it stopped at 1, right? We did not say to 1. So the default value was taken. Likewise, when you are dealing with R functions, get these things. I mean, be familiar with these things, okay? Default values. So if the values are not given, the default value will be taken, right? Okay. So now you know letters. So I was talking about letters. So let's say I want to create a DNA sequence. So one can do is, let's say my DNA. A very basic one, let's say C, G, G or something, right? So I have the sequence, right? I want to know how many base pairs are there. So I can say length, my DNA, right? 4. And if I want this as a proper sequence, I can say use the place function, right? With my DNA, with the collapse set to like this, which means without the, I'm not giving any space here, right? Open double quote, closing double quote, but that's it. If you do that, see, now previously it was, the sequence was like this, ACGT, now it's ACGG, right, as a single element. Using the collapse, we can do that. I'm very introducing these things so that, excuse me, you can work on them, right? If you need. Then now the length wouldn't work, but you have this nchar function, right? Let's say this is my my seek2, right? So if you specify this as my seek2 here, then nchar means number of characters in the sequence, right? 4, right? So these things are very useful in some cases, right? Okay. Then paste, right? Like I said, mean, median, standard deviation, variance, these things can be found using these commands, right? So here standard deviation, the variance means these are for the sample, right? Which means you are taking x bar squared over n minus 1 sample values, right? Not the population value. In the population, we are divided by capital N, population size. These are referring to the sample means and sample standard deviations and the sample variances. Keep that in mind. Right. Sequence, I talked about that already. Then we have comparing vectors, right? Sometimes we have to compare vectors. Let's say we have two data coming from 2 experiments. I want to compare them, right? Let's say I have heights 1 and heights 2, right? Let's say I want to compare them, right? So what you can do is, you don't, in a typical programming language, you have to use a for loop to go to each and every element and compare them. But in R, you don't need to write for loops. R does element-wise operation. In fact, R discourages you to write for loops, any loop basically. Most of the things can be done without using any loops, right? In R. So R does element-wise comparison, right? So let's say we have two vectors, right? Like this and this, right? V and W, if you check whether V and W are the same, right? Loosely speaking, they are not the same, right? V and W, they have different values. When I check whether V is the same as W, right? At a higher level, I can just say, no, they are not the same. But what R would do is, R is going to compare them element-wise. So R is going to go to the first element of the first vector, first element of the second vector, check. 3 and pi are different, so it's false. Pi and pi, true. 4 and pi, false. Right? So you don't need a for loop or any other loop, right, to do this type of comparison. Also, right, if sometimes we want to know how many of them were the same, how many similar elements were there, right? So again, you don't need a for loop or anything. You can use the sum function. If you use the sum function, right, if you just plug this in, that would count the true ones, right? So sum function would count the number of true ones in a logical output, right? So what I am saying is, right, let's say I have a vector x, right? 1, 2, 3, 4, 5, right? And we have another vector, right? 1, 5, 3, 7, 5, let's say. Like this, right? Then if I check whether x and y, this means I'm assigning value y to x. That is not what I want. I need to check whether x and y are the same. So two assignment operators, right? Logical expression, right? So if I do this, you can see that the first one, these elements are the same. These are not, false. These are the same. These are not, right? So what happens? So we have three true ones, right? Let me clear this so that you can see, right? So there are three true ones. If you want to know how many were similar, you can simply use the sum function. This is very important, very useful in some cases, right? So you can see there were three elements similar in these two vectors, right? The order matters. It checks element-wise operations, right? Order matters, right? Okay. Those are little things, right? Okay. Then sometimes we want to do very. Let's say I want to check. I have a sequence. Let's say Z, right? Or set of numbers, right? 10. Yes, I'll create a sequence from 10 to 20, right? I have the sequence Z from 10 to 20, right? So as you know, some of the values are even, some of them are odd, right? Let's say I want to extract only the even numbers, right? How can we do that, right? Before that, one might ask, sir, why we have 1 here, right? So there's 1 here because in order to just, recognize the element easily. So this is the first element. Let's say we have a sequence of like 1000, right? Then you can see that we have so many numbers, right? Let's say I want to know what this number is. The location, in this case, it's obvious. But if I want to identify the location or which number that is, right? So you can refer to this number. So this is the 369th number. So you go 370, 371, 372. So for easy identification, R is giving these locators, right? Okay. Now my our console is filled with unwanted stuff, right? I want to clear this to have a fresh mind, right? So what I can do is I'm going to do Control L. That would clear this. It's not going to delete anything from the memory. It's just going to clear up the console. Control L, right? So Control L, I'm going to hit Control L, right? So it cleared up, right? So if you want to refer to a previous command, you can hit the up arrow key. See, you can refer to those commands, up and down arrow keys. The history is there, right? I haven't cleaned anything. I haven't cleared any objects or anything. Of course, codes are there in the script. All I did was I erased the console so that I have a clear console, right? Now let's go back. Extracting even numbers. How do you check whether a number is even or not? Any idea? How to check whether a number is even or not? You can use the chat area to send me the answer. Right, modulo. So basically, you divide a number by 2, right? And check for the remainder, right? If the remainder is 0, then it's an even number. If the remainder is not 0, it's not an even number, right? So how do you divide in R? You divide like this, right? Like I said previously, one can just say, but it is easy to readable if you give a space before the operator, right? So I'm dividing a number by 10. Let's say 10 by 2, number by 2, right? 5. If you divide an even number or odd number by 2, right? 5.5, right? But how do you get the remainder? Remainder is obtained by using 2 percentage signs, the module operator, right? So once you divide 11 by 2, the remainder is 1, right? Once you divide this by 2, the remainder is 1, right? Right. So why don't you try this? With the logical expressions and all, now you should be able to extract even numbers. You know why I'm saying? Because you know how to extract numbers, right? You know how to get the remainder also. You know how to check whether a certain thing is certain value or not. So you have all the ingredients by now to extract the even numbers. I'm going to give you 1 minute. See whether you can do it right. Try to see whether you can extract the even numbers, right? You have learned all the materials by now, all the ingredients basically. Right? Okay, without further ado, remember I told you R does element-wise operation. So you don't need any loops or anything to browse through these elements, right? I have this vector Z. If I want the first element, I can simply say first element, right? Likewise, I can extract the numbers, right? So if I want to divide it by 2, I can do like this. If I want to extract, I mean, if I want to get the remainder, sorry. So 10 is there. Once you divide 10 by 2, remainder is 0, right? Now, how do you check whether it's an even number? You can check whether the remainder is 0. So basically, this gets the remainder. This checks even or not, right? Okay. So that is how you do it. But I'm not going to do this for each value, right? R does element-wise operation. So if I do Z divide by 2, it is going to divide all the numbers by 2. Z has, sorry, capital, not capital Z, right? Z has this much of numbers. Once you divide it by 2, it has, I mean, it divides each and every element by 2. No loops needed, right? So I can apply the same thing. So I'm gonna get the remainder after dividing by 2 and checks if that is 0 or not. Now we are done, right? So it says first one is true, that is remainder is 0. In other words, this is even. Remainder is not 0, so odd. True means even, false means odd, right? Even, odd, right? But I am halfway through because I want to extract the even numbers, right? So how do you do that? Once you plug in this output, this Boolean, this is a Boolean output because we have trues and false, Boolean, right? Once you plug in this Boolean output as this index within square brackets, it extracts only the elements corresponding to true ones, right? So you can slowly work on this, right? See, so far what we did was we checked whether the element is 0 or not. Now, after checking that, we got this logical output, right? Now what's going on? Now what happens is I'm plugging in that logical output within double quotes, I mean within the square brackets, so that it picks the elements which are corresponding to this true, right? So I have only the even numbers. Very easy. No loops needed. A single line of code could do that. It doesn't matter you have hundreds of thousands of data. If you want to do that, let's say you want to find the average of the even numbers, or there can be many applications, right? Similarly, let's say, okay, I'll come to that later, right? Maybe let's say you have a data set like this. You have heights and gender. So you can do something like similar to this. Let's say I want to find the average for females, right? So if I want to do the average for females, you can write an expression like this and extract only these heights for the females and find the average, right? I'll discuss that later, right? Which means within an hour, right? Okay, we'll moving on, right? That part is there. Then vector elements, right? So these are the vectors. sometimes it's easy for us to give, identify these vector elements if we give a name. So these are some years, right? And for each element, I can give a name also using the names property, right? If I do that, then I would have a vector like this, not just the values, but the names also, right? So then we can call them not just by the location, by their names as well. So previously we use years and 1 or 2 like that, right? So if you can say years 1, it would extract the first element. But if you want to extract this element, we can call their name as well. No need to count and go to that location and do it, right? Very easy. So what I did was I used the names property, right, of this object, and I assign some names, right? Okay. Right. Then performing vector arithmetic. So let's say you have two vectors, this vector and this vector. If I want to add them, right, not combining, I'm adding, right? Let's say a simple example. Let's say you have some marks for students, 70, 80, 35, 40. Now I want to add some marks to these students, right? So let's say I want to add 10 marks to these students. I'm not going to go to each and every element. I can just say I have this marks vector 70, 80, 35, 40. And I would say new marks is equal to marks plus 10, right? So it would, let me do this in a real quick. So marks is my vector. What were the marks? 70, 80, 35, and 40, right? Now I'm adding 10 marks to this, right? I can just say plus 10. It would go to, let me first print this marks. I'm going to add 10. So it adds 10 to each and every element. I don't need a loop. R does vectorize operations, right? And I can, so this means I'm just adding 10 and it's printing. I'm not saving this value. If you want to save that, you have to maybe give a new name or maybe the same name, doesn't matter. Otherwise, it's just gonna print it only, right? Not saving. Marks plus 10, right? So, right, okay. So if you look at the new marks now, we have the new marks added, 10 marks added to the previous original marks, right? So vector arithmetic can be done like that. So in this case, what I did was I added a constant value, right? But if you want, you can add two vectors as well. So we have the v vector and we have the w vector. R doesn't care whether it compile, I mean, the dimensions are the same or not, right? R blindly does it. For example, if you have a 5 by 1 vector and another 10 by 1 vector, R is going to add these elements. It doesn't check whether the elements are the same or not, dimensions are the same or not, right? So you have to be very careful when you are doing these things, right? So we have a 5 by 1 and a 5 by 1. So 11 plus 1 is 12. Likewise, we have the resultant vector. V minus W, V times W. V times W in the sense first element of the V vector is multiplied by the first element of W. 11 times 1, 11. 12 times 2. Likewise, you have the answer, right? Vector arithmetic, right? Let me share the code so that you can feel it, right? Sorry. One part is missing, I'm sorry. Yeah, use the second one, okay? Right. Right. Then data structures. So we talked about data types, numeric, logical, complex, character, data types we discussed. Now we are moving on to data structures. That is, how do we save these data types in R, right? So vectors we have already discussed, right? Now let me introduce some of the other most commonly used ones, right? So vectors are homogeneous in the sense you cannot combine different data types in a vector. If it is numeric, you don't go combining that with the character one. So you're going to lose that information, right? I talked some of these, right? So the other one is how to append a new value to an existing vector, right? For example, I have this value, this vector from 1 to 2, 1 to 10, right? I want to add a new value. This happens, right? In a practical, let's say we missed some value, right? I want to add that value to an existing vector. Let's say I want to add 99 to the 5th location, right? So append command is there, append new value. Where do I want to add this? After the 5th location. So first location, second, third, fourth, fifth. After the 5th, add that value, right? If it is at the very beginning, after 0th, right? So it's there. Likewise, you can add new values to the vectors, right? Then append command, right? Okay. Then recycling rule, very important rule in R, right? I told you when adding or when doing arithmetic operation, R doesn't care about the dimensions of the vectors, right? So this is let's say 6 by 1 vector, and we have a 3 by 1 vector. 1, 2, 3, 4, 5, 6, and we have 10, 20, 30, right? If you add them in mathematics class, this is not going to work, but in R class, it's going to work. What happens is these elements get added. So 1 plus 10 is 11, 2 plus 20, 22, 3 plus 30, 33. Then there's no value here, right? So R is going to recycle this value. So R is going to take this 10 here, 20, 30. So 4 plus 10, 14, 5 plus 20, 25, 6 plus 30, 36. So R is recycling these values. It's called the recycle rule. So you should know this because otherwise you will be in danger. Because R is not telling you, hey, your dimensions are not matched. It doesn't say. So you should know whether they are the same. If so, do it. Otherwise, you have to take necessary precautions, right? So R is recycling the values, right? That is what I want to say here. Okay, right. Then the next data structure I want to introduce is the lists. When you have different data types, these lists in R comes in handy, right? So you have numeric data type, character data type, logical data type, right? So when you have different data types, list is a lifesaver. So you can create a list using this list command. I have this n vector, numeric vector, s character vector, Boolean or logical vector b. I'm combining them using the list command. In addition to that, I'm giving a constant also, just for the illustration purposes. So numeric, string or character, Boolean, and additional constant, I'm creating a list. So list would be like this. So this is the list structure. right? These are called members. Member 1, member 2, right? List members, right? So if X was a vector like this, right? How did we access the values? Using a square bracket, right? Let's say 10, 20, 30. If I want the second value, X 2, right? Likewise. So now in addition to this location, I need to take care of the member as well. So I need another set of square brackets, right? For the member and the within the member, the location, right? So you can say I need the second member's third element. That is, I'm referring to this, right? So list name is X, right? That is how we do it, right? This is called list slicing, right? It's like a subsetting, right? Okay. I'm giving you a very brief idea so that when you want it, you can use it, right? Lists, right? Then another type is, so lists are heterogeneous, which means we can have different data types in a single list. So it's better than a vector, right? List can be indexed by position, right? Like I showed you, right? Okay. The other one is, okay, scalars. Scalars we talked, right? Pi, right? A single value, right? It can be an inbuilt value or some single value, right? Scalars, right? Then if you are from math side or even in the bioscience, you're gonna need matrices sometimes. So let's create some matrices in R, right? So you have a sequence from 1 to 6, right? 1 through 6, a sequence, right? Then what you're gonna do is you are going to call for the dimension. Dimension means how many rows are there, how many columns are there, right? When you call for the dimension, since this is just a sequence, it doesn't have a dimension. In R's terms, there's no dimension. But if you check for the length of a, length would be 6, right? Because there are 1, 2, 3, 4, 5, 6. But dimensions, there are no dimensions, right? So we can use this dim attribute, excuse me, we can use this dim attribute to create a matrix. So what I'm doing is, okay, get the dimensions of A. I know it's null, but get the dimensions of A and make it 2 and 3. So previously it was 1, 2, 3, 4, 5, 6. Flat file, no dimensions, but I'm introducing 2 rows and 3 columns. So now we have 1, 2, 3, 4, 5, 6, right? So a 2 by 3 matrix. So that is how you create a matrix. This is one way of creating a matrix in R. So if you're familiar with matrices, this is a matrix. You can recognize number of rows and number of columns. This order matters, right? So 1 is here, 2 is there, 3, 4, 5, 6. That is how R does by default. But if you want a matrix like this, 1, 2, 3, 4, 5, 6, you can still do it with a small option, right? So that is how you create a matrix. Then you might want to get the inverse of the matrix. You might want to multiply matrices. Very easily you can do it. For example, if you want the inverse of a matrix, that is, let's say matrix is there 1, 4, 5, 6, right? If you want the inverse can be obtained using the solve command. Little simple, little less, okay? Solve of A would give you the inverse of the matrix, right? If you have another matrix, let's say B, and the dimensions are meshed 2 by 2 and 2 by 1, right? So we can multiply them for the dot product in mathematics class. So how do you do this? This is the mathematical notation, but in R's language, you have percentage sign, asterisk, and a percentage sign, and a B. This is how you do matrix multiplication, right? If you just do A into B, it does element-wise operation, but this is not what we need here, right? We need the matrix multiplication. So you need to call this operator. Percentage, asterisk, and the percentage. This is the matrix multiplication, right? A into B, right? So we created a matrix, another data type, right? And we can do very basic or even complicated computations using matrices, right? Another way of defining a matrix is, this is my favorite method, using the matrix command, right? For example, if you are in statistics, we have this principal component analysis, right? Or cluster analysis, or even regression analysis. In regression analysis, these parameters, betas, are coming from this formula, x prime x inverse x prime y, something like this. This is how they estimate the parameters, beta naughts and beta ones, right? In the regression, y equals beta naught, right? So when you call for the regression model, it does all this in a fraction of a second and does. So R converts your data set into a matrix and does that. So in case if you want to intervene the process, here's how you create the matrices, right? So matrix, the data set, then you have to consider give the number of rows and number of columns, right? That is the second way of creating a matrix. Here again, the order matters. So you have 1.1, 1.2 likewise. So it goes like this. Columns first, then the second column, then the third column. So you can ask R to go row wise as well, right? There's a function called by row, argument matrix. Maybe I can run that. That way it's easy for you to see the difference, right? So this is my matrix, right? Data are not there, right? So this is the matrix, right? Here's the matrix. Now, what do? I want, let's say, in this direction, I need 1.1, then 1.2, likewise. So all you have to do is, when you define the matrix, right? There's this option called by row, right? So you have to make it true. When you said by row equals true, you have the required. So you see 1.1, 1.2, 2.1, 2.2, 3.1, 3.2. This is the data, right? So by row option is also there, right? Okay, so you have now at least a slight idea about the matrix data type, right? Now, as I said, the inverse can be found using the solve command. If you want to transpose the matrix, in bioinformatics, what we have is, most of the time we have genes, right? Gene 1, gene 2, gene 3, patient 1, patient 2, right? In classical statistical models, we can't directly use this. So you might want to transpose this data set into the other way around. That is patient 1, patient 2, patient 3, right? And you have gene 1, gene 2 likewise. So you can transpose it using T, right? Likewise, there are several applications, right? Diagonal matrix can be derived using this diag command, right? I'm just giving a very brief idea, right? Then arrays. When you, sometimes we have to go for more than 2 dimensions, like 3 dimensions. So the array would be the better option. So I have a 2 by 3 matrices, 2 of them. So I'm going for 3-dimensional. So this is how you create a 3-dimensional array. So you have 1 dimension, 2 dimension, and these are the other 3rd dimension, right? Arrays are the way to go when you are going for more than 2 dimensions, right? Factors, a very important data type. That is when you are dealing with categorical data. So data can be quantitative or qualitative, right? Quantitative or qualitative, right? Quantitative data means basically continuous data. Qualitative means just a label. Let's say gender, right? Male, female, or favorite color, like let's say color, red, green, blue, right? Just a label. So when we are defining these factors in R, we have, defining qualitative variables or categorical variables in R, we have to tell specifically to R that, okay, this is a categorical variable, right? Otherwise, it will be just a bunch of characters to R, right? If you just do male, female, male, likewise, R would know this is a categorical variable. For R, it would be just a character vector. So if you are using a categorical variable, you have to tell R, right? How do you do that? So by using a factor, right? So as.factor is one option of creating that such variables, right? Or else you can use the factor command, right? So when I'm defining the variable, you can say these are my levels or the observations. Okay, make it a factor. Once you make it a factor, right? What happens is R knows, okay, now this variable has 3 levels. Lose, tie, or win, right? Rather than just going with a character vector, now it goes one step further and identifies the levels. We never told R, these are the 3 levels. R identify the levels because we use the factor command when we are defining. If it is already defined object, you can use as.factor command, right? So it would convert an existing character vector into a factor, right? Okay. Right. Then sometimes we have to tell the order, right? Because what R would do is R is reading the data set and identifies the levels. But if we have a specific order, for example, we need the order to be Monday, Tuesday, Wednesday, Thursday, Friday. So we can tell R as a second argument for the factor variable. Okay, that is these are the levels and it should be in this order, right? So that we have the control over our factor, right? Okay, that's the factor variable. Then the most important part, the data frames, right? So when you have different data types, data frame is the commonly used method. For example, let's say we have the student ID, 10, 20, 30, likewise. Then we have, let's say, marks, right? 100, 90, 80, likewise. Then we have gender, male, female, male, likewise, right? So if you want to, rather than having 3 vectors, ID vector, marks vector, and gender vector, right? Or creating a list, one can create a data frame. In one object, we can store all these different data types and very easy to handle also. So how do we create a data frame? Like this. There are basically data.frame is the function to create a data frame, right? For example, I have this ID column, right? Data.frame, right? ID 10, 20, 30, right? One can like put a comma and keep typing it on the same line, but easy for better illustration, I'm taking this to the next line, right? ID, then marks, right? Marks are, I'm just giving some numbers, okay? 80, 90, right? Then gender, sorry, right? Okay, so I just created a data frame. Here's my data frame. A data frame would look like this. Typically, when we have a data set, most of the time we make it a data frame because life would be easy. So I can give a name to my data frame. Let me copy and paste it in the chat area so that you can real quick run this as well. I'm giving a name, let's say my df, my data frame. I just gave a name. Any name can be given. If you don't like this part, you can actually type them up like this, right? On the same line, doesn't matter, right? So my df is there. Now, how would I access these variables? You can simply do my df, a dollar sign. Once you put a dollar sign, it shows the available variables. So in this data frame, we have 3 columns, ID, marks, and gender, right? So if I want the marks column only, I can do a dollar sign marks. I'm working with data frames, right? Sorry, I'm commenting data frames, right? Sorry. Right, okay, marks. So if I want the marks only, I'm gonna run like this. So I have the marks. And in case if I'm interested in the average marks, my df, sorry, mean of that, right? Okay, please come up to this point. I'll give you 1 minute to catch up. Right, okay. So let's say now I want to extract the second. So this is my my df. I want to extract only the second row, right? How would I extract the second row? I can tell R, okay, my df. Now we have rows and columns. You can't just go with a single number within the square bracket. You have rows and columns, right? So I need the second row, right? So it goes like this, row number and the column number, right? My df, row number and the column number. So I need the second row, right? If I need only the first column, like this. Then if I need only the second column, but if I need all the columns in the second row, basically I want to extract the entire second row, right? You can say 1, 2, 3, like this. Entire second row I'm extracting. Right? Okay. Or else you can just leave the row number, the column number, a blank. Right? Either you include the row number, sorry, column number like this, or you leave it a blank. Both would be the same, right? Similarly, if you want to extract the third column, right? One can do my df, sorry, all the rows. So I'm going to leave it a blank of the third column. So third column would get extracted, right? All right. Okay. Then so let's say I have this data set my df. I want to extract only the male students, marks of the male students, right? So how would I extract the males? I have the my df gender. I'm checking whether it's male, right? Only males, right? So I have a logical output. Now if I plug this inside the square bracket, then only these true ones get extracted, right? So what do I need? I need my df marks of the male students, right? So these are the marks of the male students. So it's correct, right? So this is a male, this is another male, so 190. So now if you do a mean of that, mean of the marks of male students, right? Okay. So that is how you work with the data frames, right? Okay. So let me share the code with you. Right. Now writing our own functions, most awaited topic, right? So far we have been using some analysis codes like functions, right? So we have been using the mean function, sum function and all these. But let's say I want to write my own function, right? For example, I want to write a function to add 10 values to any given number, right? Let's say x is there, x is a sequence from 10 to 15, right? I want to add 10 values to that, or else for any given value, I want to add 10 values. So I'm going to write a function. Here's how I would do it. I'm going to say I have to first give a name to the function, right? Function name, right? Then we use the keyword function. Then we have some arguments. Then we have the body. That is how we write functions. For example, let's say add 10 is my function, right? So I'm going to do function. Let's say my input is y, right? When the y is given, what should I do? I should print y plus 10. I'm done defining my function, right? So this is basically the definition, function definition, right? Now I have to run this function. So it ran without any issues, right? Now I'm calling the function, right? So at 10, you have to call the function name, and within the parentheses, you have to specify the value. Let's say I'm using 100 as my input. 100 was the input. I'm adding 10, so it's 110, right? Very easy. Writing your own functions, right? Similarly, one can write a function to convert miles into kilometers, right? Miles into kilometers. How do you do that? Let's say miles to a kilometer is your function. Function is the keyword, right? Miles is the input, right? Then you are giving 1 mile is 1.6 kilometers. Okay, that you should know, right? So then you are print miles into 1.6, right? So this would be the function, right? Let me call the function miles to kilometers. If it is 10 miles, then when you're calling the function, you can say miles equals 10, right? Or else you can just say 10. There's only one argument, so it doesn't matter whether you specify the argument name or not, right? Okay, so if you want to make it a little bit fancier, you can use the stuff we learned so far. We learned the cat, remember? So you can say cat, right? Miles is kilometers, right? So then I'm going to do miles to kilometers. Let's say 50. Sorry. 50 miles is 80 kilometers, right? Let me, let me share it with you, right? So I incorporated cat command so that I can combine the variables and some text, right? Cat, okay? Is it clear, the function part? Hit yes or no, just to see whether it's okay. So was it okay, the function part? So you need a function, then the input, then the body, then you have to call the function, right? Right, thank you. Okay, that is how you write your function. So you can, as a homework, which I'm not going to check again, you can write a function to convert. You can, yes, there are so many to remember, but don't remember everything because everything is there in the internet, right? So you are not taking a class, you are applying these things. So when you practice only these things come into your, I would say, bloodstream, right? So homework, write a function to convert Celsius temperature into Fahrenheit, right? One application, right? Okay. So that is about functions, right? Then I have covered all this. So now reading external data, right? So reading external data is again a very important topic because we cannot every time enter the data into the script and do it. Sometimes we have to read external data. For example, for today's class, I have given two data sets. I think you can see this, right? My screen is there. So data CSV, that is a comma separated value file, CSV file, right? And the other one is a text file. So first of all, let me show you how to read in external files, right? reading external data. So I have set my working directory already. Now all set. Otherwise, I had to give the full path. So the command to read the text file is reading a text file. Read.table. Right? Read.table is the command. Right? Then you have to specify the file name. What is the file name? So what is the working directory? First of all, we'll check for the working directory. Get wd. My working directory is this, R for research folder. And let's see whether this file is there. Okay, it is there. See, my text file is there. Now I'm reading that file, right? The name of the file is datatext.txt, right? Within double quotes, file name, right? Once you read it, it reads the file, right? Okay. But something is off, right? Because the variable name was read as the first record. In a data set, typical data set, right? In a data set, you have the variables, variable 2, right? And observations, right? These are observations, observation 1, observation 2, these are variables, right? And this is variable names. So variable names are there. So we need to tell R, okay, the first row contains the variable names. In other words, we have to tell header is equal to true, right? We are telling our variable names are there, right? Header is equal to true, right? Then I can assign this to an object so that I can use it further, right? Let's say my text data, right? So when you are giving variable names, you cannot give spaces. That is also important. You cannot give spaces when you are defining an object, right? Also, you cannot start with the numeric digit. A number, you cannot start like that. So when you are giving an object name, that cannot start with the number. Also, you cannot have spaces like this, right? So one option is, I usually use this camel notation, right? Camel notation, right? So I use my, then the second word, first letter capital, text, third word, first letter capital, data. So this is the camel notation. Okay, or else you can say my first letter also capital, right? Some people use my dot text dot data, that is also fine. Some people use underscores, text underscore data, that is also fine, right? All these are fine, but consistency is the key. So you have to stick to one convention. Don't use all of these in a single set of codes, right? Okay, so my text data, then what I would do is I'm going to assign this into that object, right? Now all set. See, I have this my text data object already created under the global environment. So global environment actually shows all the objects that are available globally. That is, for any program written on this session, I can access them, right? Global environment. There are some private environments as well. That is, those are restricted only for that particular set of codes, right? Okay. So my text data, right? Then I'm gonna, if I want to have a look at my text data, right? This is there. Now, if I want to extract, let's say the code variable, a $sign. So when you read in data set using read.table, what we are creating is a data frame. So then all the data frame techniques are available for that particular data set. For example, if I need, so this is a data frame basically, okay? This is a data frame. Right? Okay. So if you want to access only this particular variable like this, let's say if you want to access only the second row, all the columns. Likewise, you can use data frame techniques, right? Okay, so reading text files. Sometimes we had to read in CSV files. So the command would be read.csv. So the name of the file is my CSV data, I think. I'm not sure, so I'm gonna look at the folder, right? Yeah, my csv.csv, right? Sorry, data csv.csv, right? So here you don't need to tell R that, okay, the first row has the variable names. Read.csv automatically search for the variable names and reads it, right? So that is how you read a CSV file. Let's say you have you don't like coding, so you can still do that. What you have to do is you have to go to this environment tab right here, import datasets, right? So you can do import dataset, then you can import Excel dataset, SPSS, SAS, Tata, test, anything, right? Let me open, let's say test dataset, right? Then a window would come like this. I have to specify the dataset. Then a wizard would guide you, right? So this wizard, what it says is it has the file name, right? So not the file name, the object name. So if I need my text data or something, I had to give the name. Let's say this is my text data 2. I had to give that name. So here's the input file. It says variable headings are there, yes. So I mean, this wizard has recognized them and it does a decent job. So once you are done with it, so it shows a preview as well. So it has identified this variable name. So you hit import, then it would show you a preview like this as well. Now you can go to the script file and you can start using that data set, my text data 2, right? But the thing is, if you do from the menu, each time when you are running this code, you have to do it like that because that code is not there saved in the script. So tomorrow when you are running the code, you have to go to this menu and import it manually and give the same name. But if you do it using a code, it will be there. So each time all you have to do is just run the code. That's it, right? One way to reduce the workload is you can import the dataset like this from the menu, and you can copy that code from the console and put it here, right? That way it's there. So it's there. So you can, the next time you can just copy and paste. So this forward slash and backslash, those were converted nicely. You don't have to worry about them. The headers were taken care, right? Very easy, right? Nowadays I'm doing that, right? I'm not writing the code from scratch. I just go to the menu, but copy it and bring it to the code, right? Okay. Then we have give me a sec. Sorry. Here is the data set. Then what's next? Right. So reading Excel data, there are several packages available. Yeah, now it's time for me to introduce packages, right? So packages in the sense, when you install R for the first time in your computer, right? So you first install R, then RStudio, right? So from the cloud, right? From the cloud, R CRAN site, right? You download this R software and you install it in your laptop, right? So some packages like base, stats, these packages get installed in your laptop or in your computer. So this base package has this main function, the SD function. These essential functions are there. So basically, a bunch of functions, mean, SD. These functions are a collection of function is what we refer to a library, right? So when you consider a library, what happens is there are a bunch of functions. So these libraries are actually saved as a package in the cloud. So when we say a package, our package, right, what we are referring to is a bunch of functions. So when we install a function, when we install R for the first time, some of these packages come to our computer, they are installed as libraries. So no issues. But when we are referring to some additional packages, like some fancy packages, reading an Excel file or some fancy plots, like grammar of graphics, right? ggplot2, like packages, or some psych package for psych. I cannot recall the exact name, right? So we need to install them manually. So how do we install these packages? So this is how we would do it. You can go to the RStudio, right? And you need to install them manually. So you have to go to the packages tab, right? Then hit install and type in the name of the package, right? It will, yeah. So you have to type in, let's say I'm dealing with some time series data. So T series is the package, right? So I'm installing that package. Then only the functions coming with that package are accessible to our R sessions. So it got installed in a real quick, right? Now we have installed it. After installing it, so installation is a one-time thing, right? Then each time when we are opening R or within an R session, we need to load that library, right? So each time in each R session, if you are reading a function, if you're using a function that is coming with these additional libraries, you need to load them. How do you load it? Using the library command. Right? So you do library, then I will do at the end, okay, Prabha? So library, then package name T series. So this would load the package into the session, right? So maybe I can show it in a real quick again. So you can go to the packages tab here and install package. Then you can give the name. Then hit install, it will install the package. So it's a one-time thing to a computer. After installing it for each R session, you have to load that package. Then only the functions which are available or which are coming under that package are accessible, right? Okay. Then, right. That is installing additional packages. Or else you can go to this packages tab. Instead of running this library command, you can just select that package. For example, I can go to the T series package. It should be here. T series. Right? See, it's there, so I'm gonna select that. It would run the package, the library command for us, right? See, library command was run by RStudio. OS, the old school ways, or the proper way, or the co-programmers way is writing the command. You say library T series, right? This double quote is optional because now R has already installed that option package, right? That is how you install additional packages, right? Then right, if else statements, right? So if else statements, like in any other programming language, we have these conditional statements, if else. So this is how if else work in R. So we have, let's say x has this value. Here's the condition. If that condition is true, do this, otherwise do nothing, right? So x is 5. If x is greater than 0, print positive number. So in a real quick, I can illustrate this, right? So x is 5, right? I shared the code with you, right? Now let's change the value to a -5. X is -5. Once x is -5, it does nothing because it's negative. If x is positive, do this. Now let me change the code a bit, introducing the else command, right? Print negative, let's say, in short, right? So if x is -5, it prints negative. If x is +5, it prints positive. So this is how we do if else in R, right? Let me share that code as well, right? If and else, right? Okay. If female do this, if male do that, likewise you can think of applications, right? If and else, right? So you can nest multiple if else like this. So you have if, then else, under that else also you can write if else. Likewise, this is a nested if else case, right? So this is how in a typical programming language also work. But in addition to that, in R we have this if else statement, sorry, if else function, right? So then we have to specify, write down the condition. If x is positive, right? Give positive, otherwise negative, right? So one line, right? If x is positive, it prints positive, otherwise negative, else. So let me change the value of x in a real quick. -5. So it says negative, right? Okay. That is how if else work. Let me share that code as well. I will share the R codes in the shared folder after the class, okay? After the workshop. Right, then loops, another important topic, right? So in a typical programming language, let's say in C++ or something, so in a for loop, we have to say int x is equal to 0, then until x is less than 10, x plus plus, right? Then you can say the command codes, right? But in R, you don't need this declaration part. You don't need this increment part. It's very easy. You can say for x in uh, so this goes from 0 to 10 means 0 to 9, right? Excuse me. So this is x is less than 10. So this basically goes from 1, 0, 1, 2 up to 9, right? So if you want to repeat the same thing in R for x in 0 to 9, then the body. That's it. Very easy in R, right? This is in C++, right? This is in R. So you don't need to declare the variable. You don't need the increment operator. Everything is inbuilt. So you have this for and in, that's it. So here you have to give the range, right? So let me run that in a real quick. A for loop. For I, let's say I, or else you can say x in 0 to 9. I'm going to print the value of x. That's what I'm doing, right? So I have the print. I'm printing 0, 1 up. So this is a very basic for loop, right? If you have something like this, let's say a some letters, say sorry, A, B, K, sorry, L, likewise. Then you can feed that inside as the for loop as well. So you can say for, let's say I in A. Without giving a range, you can specify a vector as well, like this. Then you are printing I, right? Okay. So for I in, sorry, A is not updated. So this is the previous A. So I need to first run this command, right? A, then see A, B. If you have something numeric also, you can do that. So let's say you have some B or something. 10 to 50 B, right? So you are printing that. Simple as that, right? So for is the most commonly used loop in R, but we have the while loop and the repeat loop as well, right? For example, yeah, let me in a real quick talk about this next statement. So what this next statement does is it skips the that particular iteration. Probably you have seen it in other programming languages. So let's say x is from 1 to 5, right? When the value is 3, next, which means don't go beyond this point, go to the next iteration. So when x is 1, or in other words, when the, so this means 1, 2, 3, 4, 5, x 1 to 5. So value is 1. Value is 1 means it does not satisfy this condition. So it's printing 1. When the value is 2, it does not satisfy. So it's printing 2. When the value is 3, it satisfies this condition. So it comes here, next, which means go back. Don't print. So 3 is not printed. See, 3 is not there. Next, go to the next iteration, right? Okay, then that's next, right? Then if you want to stop the loop, you have to use the break. So in this case, x is from 1 to 5. So value is the iterator. If value is 5, break it. So after the second point, it's not printing anything because the loop got broken, right? Okay. Yeah, that is what the loops are. So while loop, in the sense, here you have to give this increment operator separately. Okay. So condition is there. Increment operator, you have to additionally give that. Whereas in the repeat loop, in addition to the increment operator, the break rule has to be also given. How to break the loop. Otherwise, it will keep on running, right? Let's say in a while loop, let me run this, right? Don't try this. Please do not try this, right? So when I, let's say I forgot to increase the value. So I is 1. Here this arrow means equal sign, right? Same thing, right? I is 1, while I is less than 6, print I. So it's still printing. Why? Because in the first iteration, I is 1, right? It's printing 1. Then in the next iteration also, I is 1. So it's printing 1. It does not stop. So it's printing. And now my computer is going to crash, right? Why? Because I can't stop the loop. So you can restart the computer, or else you can stop this one. See, there's a stop button here. So you can hit the stop button, right? That way you can break the loop, right? Or else terminate the program, right? So now we are, so I can increase the value 1 by 1, I plus 1, right? So now what happens? I is 1, right? So it's printing up to 5, right? Okay, so it's time. I'll take 2 minutes and finish this off. Sometimes we need to save these values, save some values inside a loop. For example, I want to save these values, right? Let's say I'm gonna take I. I'm gonna multiply it by 10, and I want to save that value. So what I can do is I can create a vector, let's say some number, let's say j or something, right? So if I do j, what happens is in each iteration, this value is saved in j. But there are like this much of iterations, 10 to 50. So if I want to save each and every value, I need to refer to a vector, right? So like this. So go to the ith location, then save this value, right? So that is how we save a value. But in order to access the ith location in this j, we have to first tell R that, okay, j is a vector or basically an array. So this is how we do it, numeric array or numeric vector. Then R would know that, okay, there are several locations available, so I can go to the ith location. Otherwise, you would get an error, right? This is how you would save values inside the loop. Saving values, that is also important in some cases. Inside loops, inside the loop, let's say. Now, if you print j, right? So you can, because you don't have the first 10 values, right? It goes from 10, so you have missing values, right? That is what happened. All right. And lastly, let's say I want to find the mean of j. I want to find the average value of this vector j. If I run it, it says NA. NM is not available. Why? Because there are missing values. Whenever there are missing values, at least one missing value, you can't find these averages. So you need to tell R, okay, what to do about the missing values. So there's this argument na.rm. You have to set it to true. na.rm is missing, remove. RM for remove, name is missing. When there's not available data, remove, set to true. So it's removing these ones and finding the mean, right? Capital J. R is case sensitive, right? See, now it's 300, right? So that's it for today. Next time I'll show you how to do data visualizations and do basic modeling using R next week, right? Thank you. And if you have any questions, you can ask now. I'll be waiting for a couple of minutes. Others can go. Thank you. So there's a question. So can you please teach us? Yes, we'll do. We'll do how to do that. Yeah. Prabhat, I hope I answered your question about the importing, installing the package, right? Any specific questions? I'm sorry, I might have skipped one or two because of those were too specific. But if you are still there, you can ask now. Yeah, sure. I will share the video and the slides with you. Okay, in the chat, in the shared folder recording. Yeah, sure. I'll share the codes as well. Save all option would save the scripts only. Objects you own. Objects you have to separately take care of.